Software development is one of the coolest things on the planet. It actually rivals doing actual physical engineering where you're building skyscrapers or giant ships that sail the ocean. It's just instead of doing it in a physical world on a macro scale, you're doing it in an imaginary world on a micro scale using imaginary languages that we've made up that allow us to communicate to computers. Now, in the world of software development, the development that actually happens is very nonlinear. It doesn't follow a straight path. It's actually all over the place. And because of that, it's important that we understand the software development workflow. So we're going to be getting into that now. So get ready. It's going to be awesome. Now, before we jump into deeper, more complex software development topics like programming, software architecture, any of those deeper subjects, let's go ahead and let's talk about the software development model or the software development workflow. In other words, the way in which software is developed over time when there are groups of developers working on that software. Of course, when you're just building software by yourself, the process is pretty simple. It is pretty linear in how it is built, and really you only have to worry about yourself. But when you build software that is complex and on a large scale, and you're using teams of developers to do that, the complexity of that software development process becomes substantially greater, and actually it just increases over time in a very crazy way. And that is because the more people you put into the mix, the more conflicts arise, the more that source code is being operated on, manipulated, and modified by different individuals, sometimes at the exact same time in the same piece of, or the same file. So for that, let's go ahead and let's direct ourselves to this development workflow that I've got here up on the screen. Let's talk about how the software development workflow works and why it is said to be nonlinear. In other words, it doesn't follow a very specific path from point A to point B from beginning to end. In fact, it takes many different paths, and those paths are taken by many different developers at different points in time. And so let's jump through that really quick. That way we have a good solid understanding of the software development workflow and how it is impacted or how it is affected by teams of developers. Now, right here, I've got myself a pretty simple software development workflow drawn out. It's one that I have used quite frequently throughout my career as a software engineer over 19 years. And so we're going to go through this one step at a time so we understand what the different statuses are, what's happening to the code or the software at that point in time. And we'll do that from a single developer point of view, and then we'll jump into what happens when there are multiple developers. So if you can see my arrow, my cursor right here on the screen, we're going to start off right here where a piece of software is ready to be built and we have defined requirements for it. Those requirements could come in the form of a requirements document, a feature list, or in actual user stories that have been written up by a domain expert, somebody who understands the world for which we are building the software, like the medical world or the business world or finance world. Any of those would be a business domain. And so these user stories, these functional requirements, or to-dos, if we want to keep it really simple, are usually written by somebody who has been interacting with a domain expert within that domain to find out what's needed for the software. Now, when those to-dos are created, they go into kind of a backlog or a to-do list. I'm going to go ahead and use to-do because I think most people are familiar with that. So there's a list of things that need to be done. And they're usually ordered chronologically so that you can keep a list and things are being done in the order they should be done. And so you've got this massive to-do list right here. And then when a developer is prepared to work on the software and start building out those features, they'll go ahead and pull the to-do off the stack, off of the list, and then they'll move it to an in-progress status. Now, when that task is moved into an in-progress status, that tells you that is actually work is being done. We are now working on that particular one. Now, when it's just a single developer, really no one else really cares about the status that it's in. And so it goes from to do to in progress. Usually the developer is working on it. The developer then goes down here to in review, which kind of happens at the same time they're building this, because they're just going to go ahead and review it and make sure the code looks right and it works and it's done the way they want it to be. And because there's no one else to look at that software and to verify that what they built is correct, it usually goes directly from in progress / in review as they're developing it, and then in test as well, because you probably don't have a massive QA department. If you're a single developer, you're probably also testing the code yourself. So that's all going to happen on your computer on one machine. And so these particular, let's go ahead and point them out. This one, and this one usually all happen on that one developer's machine, and it kind of happens in this natural flow. So as they develop some code, they test it live, they review it, they test it, they build it. And so it's just kind of like this little loop right here as they're completing a particular task. Once that task is done, in other words, they've reviewed it, they know it's working, they'll go ahead and mark it done, and it is now a completed to-do item. And then they'll grab another one and move on. Now, some of these other statuses like blocked, and then some of these other process lines that show a change in status don't really, or are not really used by a single developer. They come into play when we're working with an entire team of software developers. So you can see how with a single developer, the development workflow is kind of linear. It really does just kind of go in this straight path to completion. Now, where it gets complex is when we add a bunch of team members to it. So let's go ahead and add another screen. And let's talk about how this works when we've got multiple developers. This is where the complexity comes in software development, is when we have one code base, one set of files that house all of our source code for our program or our software, and then we have more than one software developer. Now, just like with the single software developer, we may have multiple developers that grab multiple to-do items off of the to-do stack, and they move them all into this in-progress status, and they begin to code. Now, some of these to-do items or some of these features might actually be interrelated to each other, meaning that as you're building out these features, you might actually be touching the same source files or the same files that house the programming code for our software at the same time, which means they're editing those things at the same time. And that can cause a lot of conflicts. And we'll get into that when we start talking about source management, which comes up next or later on. So here we've got 3 developers right here pulling to-do list items out. Now, if they begin working on this, they might find that their actual task that they're working on might actually be dependent on something else. And so one of their tasks might end up going into a blocked status where they're waiting on something else to get done, and then they may go grab a completely different to-do to begin working on while their task is sitting in the blocked status, waiting on some code from another developer to be written. So now we've got a task sitting up here in this blocked status, and we've got 3 tasks right here in our in progress. Now, as they're working on that code, they're kind of reviewing and testing locally, like we talked about when we talked about a single developer, but that's all considered to be happening right here in this in progress status. They're on their machine as a developer, they've pulled down the source code, and they are working on their features, running it locally, reviewing their code, testing it to make sure it works until they think it's good to go. Once that happens, those tasks are then going to move down here to the in review status. Now, in review, the reason why I have this specific status in software development is because when we're in a team, usually we have a lead software architect or a lead developer or a senior developer who is in charge of code reviews. And so as developers complete their tasks and they submit it for a code review, then we have a bunch of developers get together, usually the team, with the software architect or the lead or senior engineer, and they're going to go through all the code that has been checked in by various developers over the last little while. Maybe it's once a week. They look at all that code to see if, number one, it looks effectively done, it's following the coding standards that they have, that there aren't any glaring mistakes or any glaring security issues or any glaring inefficiencies, like if the developer was using really poor coding practices and they wrote, code that would run really long instead of using a shorter, more effective algorithm, they might be using a really ineffective algorithm. So this review status is really for software engineers, software architects, to really begin to review code and learn from each other about the code and everybody's varying experience, and then also to make that code clean, clear, well-written, efficient, and safe to the best of their abilities. So that happens right there. It's a really important step, and it's a really good step that sometimes is forgotten, but this is an opportunity for code to be written better and for developers to learn from each other better coding practices and or more efficient algorithms or ways of doing things. Now, once that code review is done, if it doesn't pass, in other words, the software architect doesn't think it was good enough, or the senior engineer, they may send it back to the user as a to-do item, saying, hey, I know you've got all these other tasks you're working on right now because you turned this in. We're going to go ahead and put it back in the to-do with your name on it so that you can get back to it because there are a couple of things we saw that need to be fixed. And then it would go back through this process right here. Now, if it does pass the review status, this code review, then it would go into our test status. And usually, if you've got a large software development team, you usually have a developer dedicated to QA, or else you have an entire QA team or quality assurance team. And it's their job to make sure that they test all the code that has been checked in and completed, reviewed by the team, and then we think it is ready to be sent to production. So usually you're going to have a QA team and a QA environment or a quality assurance environment where you have a bunch of test servers or test computers where the software is going to be tested by actual testers who are really good at breaking and finding issues and making sure that the software works the way it's supposed to. Now, if the QA finds something wrong with it, they, of course, can return it back to the to-do status and reassign it to the original developer to go back and fix a bug, or if a feature is not working quite right, to make sure that they go fix that, or the user experience isn't correct, and they'll fix all of that. Now, and then it'll come back through this process again. Everything goes back through the process. And you can see why I say that software development isn't linear, because here we've got it going through a bunch of different paths instead of one solid path. It's going very specifically. There are very laid out paths that the code can move, but it isn't linear. It can go very circular, and it can be circular on very different paths. Now, if it does pass QA, in other words, the software that was written does meet all the specifications, it doesn't break the software, no new bugs are found, all of the features work as they're supposed to based on the requirements that were provided, then it can be marked as done, and then that code would then be sent out to be pushed to our production server. And then once it gets pushed to production server, there's some testing that goes on from the testing team. And if everything works great, then that code is now live in production, and everything goes back through the next process for the next iteration or the next set of features to be developed. We call that iteration, or the iterative process of software development. And that's really the software development workflow. Now, there's a couple of ones we didn't touch on here, like postponed. If for some reason a software developer starts working on something and then it's not really blocked by something else like we saw here earlier, but it really is just a feature that's decided we don't need to do, but some code was written on it, it may just be put into a separate branch and then postponed so it goes back to a to-do status waiting to get done when it's decided that feature should be put into the software. So that's postponed. And then, of course, we saw where we had put a task up here into the blocked status. Well, once whoever's code this particular task was dependent on gets it done and goes through the process, then it may go back to in progress, or if we want to get more complex, it could go back to just to do. I didn't include that process right here because it doesn't happen very frequently. Most of the time, any blocked code, as soon as the code that it needs is done, it's going to go right back into in progress, and then it's going to go through everything. The other one we didn't really talk about is the reopened status right here. Sometimes, even if it goes through the entire phase and everything is perfect and the task is marked done, sometimes you'll find that the domain expert or the business people making the request, once it's all pushed out there and it's out there, sometimes they might say, oh man, I actually meant for this particular feature to actually do this. a little bit different. In other words, it's almost right. It's about 99% right. I just want it different. And so sometimes you might reopen a task, put it back into the to-do, maybe assign it to the exact same software developer, and then it goes back through the entire process. That's kind of rare because usually if it's already made it out to production and the business people come back and say, well, we really wanted it to do this or we want it to do differently, because that task was executed the way it was originally designed and met all the requirements, we most of the time don't reopen them and put them back in the to-do. We usually just create a new to-do item and we put it back, we put a new one in the list, leaving that other one as complete. But I did include it there because sometimes it does happen. Sometimes it is a useful status or a useful way of moving something that was done, maybe needs a little bit of an alteration, and it was done recently. Maybe you do just save some time, add the one line of what needs to be changed to that old ticket, and then reopen it as a to-do, put it in that to-do list, and then wait for somebody to take on that particular one. The other thing, of course, is the canceled. If there's a to-do item in the list and then the business or the domain expert or the business people decide that they don't actually want that anymore or it's not applicable anymore, because business does change, requirements do change, and they change pretty quick sometimes. So maybe when a developer's about to pull this out, or the project manager or whoever's managing the to-do list, when they see it, they're like, oh, wait a second, this is no longer applicable. We're not going to build that into the software. It's not a feature we want anymore. They'll go ahead and pull it out and probably cancel it. And by canceling it, it remains an active card. It remains a card inside of your list, but it's marked as canceled. So then it goes into kind of its own status. And that way, down the line, if for some reason that particular requirement comes back up, you might want to go search through the canceled, find it, and then kind of evaluate the way they want it done now compared to the way it was in the past. And use that as kind of a way to proof that the new requirements and the old requirements are either identical or they're different, and then maybe raise the differences to the domain expert in order just to make sure that they really do want it the new way, or the old way was actually designed better, or they're missing some stuff in the new one that they might want to pull from the old one. Anyways, it's kind of one of those records or historical record that might come in handy later on. And that's why a lot of times you include a canceled status on these requirements or these to-do items that are in your software. Now, hopefully that shows you that this software development workflow, or the way software is developed, is definitely not a linear process. It's not something where everything happens exactly the way you want it to, or in exactly the same way every time, and it doesn't follow the same order. It can go all over the place. Now, because the software development workflow is so non-linear, it opens it up to a bunch of problems. And we already talked about some of those where you might have developers that are working on the same source files, and as they're building out these features, they might actually overwrite each other's code because they're working in the same file, but they're working on it on independent machines. And that is where, because of the non-linear reality of software development, we end up needing source control, or a way to management. They also call it source management, but a way to manage the source that we're manipulating as we go through the software development workflow. And that's really important. And that's what we're going to get into when we learn Git.